There are thousands of space rocks of all different sizes floating around in our inner solar system, and many of them are moving on a path towards us. These objects are called asteroids, and recently NASA has made some startling discoveries. You may have heard the news that an asteroid is hurtling towards the Earth, and you may have also heard that it's scheduled to wipe us out on November the 2nd, 2020. So, should we really be afraid of an asteroid impact? And if yes, what should we expect? Will humanity finally find a way to destroy huge, dangerous asteroids before one wipes us out? The asteroid we're talking about was discovered in 2018 by the Zwicky Transient Facility, which is an incredibly giant telescope in Palomar, California. NASA is calling it the 2018 VP1 asteroid, and it's about the size of a car. As asteroids are concerned, it's not huge, but the fact is, it's heading straight for us. If you take a look at Earth's orbit and the trajectory of 2018 VP1, you can see that it's coming awfully close to the planet. But there are some problems when it comes to knowing if an asteroid is going to smash into us or not. That's because it's hard to track the path of asteroids out there in space and predict where they're going to go. This is because some of them are too small and dull. In fact, even though 2018 VP1 was spotted a couple of years ago, NASA lost track of it and didn't know where it was. Even with advanced telescopes and dedicated observations, it's still very hard to understand where an asteroid is going to go. There are many things that can change the path of an asteroid. It can change path just from the heat of the sun, or another nearby wandering space debris, or even a planet can alter the course of an asteroid that could send it on a collision course with Earth. Asteroids hitting Earth really got people's attention after the recent Chelyabinsk meteor incident in 2013. This chunk of space rock was approximately 66 feet in diameter and entered the Earth's atmosphere over the southern Ural region of Russia at a speed of approximately 42,900 miles per hour. Although the asteroid disintegrated before hitting the surface of the Earth due to the intense heat produced by its entry, it still caused a fireball which was brighter than the sun and was visible up to 60 miles away. Some eyewitnesses also felt intense heat from the fireball. And then on August 22, 2020, it was claimed by NASA that an asteroid was headed towards Earth and would enter the atmosphere on November the 2nd, a day before the US presidential election. What immediately followed was shock headlines and social media posts sensationalizing the announcement. And because 2020 had already served up devastating bushfires, hurricanes, and a global pandemic, many people have become legitimately scared that even more devastation was headed our way. But it would seem for now that there is nothing to worry about, because asteroid 2018 VP1 is unlikely to hit Earth and should pose no threat to humanity. This asteroid was discovered by NASA back in 2018 while it was 280,000 miles away from Earth. It's estimated to come within 2,796.17 miles of Earth on November the 2nd. That's really close in space terms. There's a slight chance, about 1 in 240 or 0.41%, the asteroid will hit the Earth. However, the asteroid is so small that even if it enters our atmosphere, it's likely to disintegrate into a fireball and break up into 1 million pieces before reaching the surface. This recent scare caused by this close flyby shows it's the right time to analyze the effect asteroids have on our planet. Since the beginning of recorded history, there have been multiple records of asteroids impacting the Earth. Slightly over 65 million years ago, an asteroid, now known as the Chicxulub meteor, which had the diameter of between 10 to 50 miles wide, slammed into the Gulf of Mexico and started an extinction event that wiped out nearly 75% of all life on Earth and is credited with the extinction of the dinosaurs. Elsewhere, mammoth craters of blasted-out Earth have been discovered from the continental United States all the way to Russia, such as Barringar Crater in North America, Gosses Bluff in Australia, and Lake Bosumtwi in Africa. In reality, the chances of that happening within our lifetimes are fairly small. Our solar system has an entire region between the orbits of Mars and Jupiter known as the asteroid belt. This belt is estimated to contain between 1.1 and 1.9 million asteroids larger than half a mile in diameter, and millions of smaller ones. Between 1988 and 2017, NASA counted over 700 fireballs created by different sizes of space rocks entering our atmosphere. In order to detect asteroids, NASA takes multiple pictures of the night sky and uses computer programs to scan for moving objects. These observations are made from multiple locations all over Earth, and as the planet rotates, several observations are made that keep track of the orbits of all asteroids and determine how close they are to Earth. The nearest asteroids are called near-Earth objects, or NEOs, meaning they orbit at roughly a third of the distance from the Sun. There are over 20,000 NEOs that are known and are currently being tracked. Based on the object's speed and brightness, scientists can map a trajectory to predict whether it will collide with Earth. If an NEO's orbit crosses the Earth's and the object is larger than 450 feet across, it's considered a potentially hazardous object, or PHOs. The impact energy of a 30-foot diameter asteroid is projected to be around 100 kilotons, but the larger the object, the deadlier the impact. A PHO with a diameter of around 500 foot, just a little larger than the Great Pyramid of Giza, has the potential of generating approximately 300 megatons of energy on impact. For reference, the number of megatons that was produced by the explosion of the most powerful nuclear weapon ever created and tested, the Tsar bomber, was only 50. This kind of asteroid strike could have the potential to cause millions of deaths and the destruction of entire cities. But the most worrisome thing is that asteroids don't always have to impact the surface of the Earth to cause damage and destruction. The Chelyabinsk meteor mentioned earlier dealt a lot of damage despite not hitting the ground. The blast created by the asteroid's airburst produced extensive ground damage over an irregular elliptical area around 60 miles wide and a few tens of miles long, with the secondary effects of the blast being the main cause of the considerable number of injuries. Russian authorities stated that 1,491 people needed medical attention in Chelyabinsk Oblast within the first few days, and over 7,200 buildings were damaged with collapsed roofs and shattered windows. That's why many nations around the world are scanning the sky for NEOs in an effort called Space Guard. The initial goal of the mission, to catalogue at least 90% of NEOs that are at least half a mile in diameter and could cause a global catastrophe, was met by 2011. Now the survey has been expanded to catalogue and track smaller objects which have the potential for large-scale, though not global, damage. For now, we are safe. But what if we spot a large asteroid coming towards us? What actions could we take? Our ability to prevent a devastating asteroid impact depends on how big the asteroid is and, most importantly, when we detect it. For example, a PHO on a path to collide with Earth, if detected 1 year out, is almost certainly going to impact us. The only thing to do would be to evacuate the impact zone. However, if it was detected 7 to 8 years out, then we would have a real chance to deflect the object. Currently, scientists have proposed various ways of doing this. The first method proposed is to detonate a nuclear device on the surface of the asteroid, or near it, so that the blast either breaks up the asteroid or pushes it onto a different trajectory. If the asteroid is far enough away, it'll only need to be pushed a few inches to bring enough change in its trajectory to miss Earth. Despite the risks of fracturing the asteroid and the unpredictability of debris after such explosions, this method of impact avoidance is still the most serious contender and has resulted in the creation of a conceptual Hypervelocity Asteroid Intercept Vehicle, or HAIV, which combines a kinetic impactor to create an initial crater for a follow-up subsurface nuclear detonation within that initial crater. The second, less drastic method to come out is the kinetic impact method, which literally uses a spacecraft as a battering ram to change the trajectory of the asteroid in question. This method has received major support from NASA in the form of the Double Asteroid Redirection Test, or DART mission, which is currently in its final stages of development and proposed to launch towards the target asteroid in the second half of 2021. The DART space probe's target is a PHO-sized asteroid called Dimorphos, located in the Didymos binary asteroid system. The idea is to impact the asteroid at a substantial velocity to initiate a trajectory change. The Didymos asteroid system is not in any Earth-crossing trajectory, so there is no possibility that the deflection experiment could create an impact hazard. If successful, this mission will be the first ever proof of concept towards asteroid impact avoidance. Other concepts include ideas such as the asteroid gravity tractor, where a spacecraft orbiting near an asteroid is theoretically enough to bring about a slight change in its trajectory due to the spacecraft's gravitational pull and the size and mass of the spacecraft. This system can, over time, redirect the asteroid, pulling it away from the Earth. Then there are proposed concepts such as focused solar energy and asteroid laser ablation, both using directed energy to cause jets of material heated by the solar energy or high-powered laser to fly off the surface of the asteroid, and that is essentially the equivalent of a jet engine pushing the asteroid off course. All these ideas are fundamentally strong, but need to be tested one by one to prove their effectiveness, and this will take time. So far, scientists and astronomers have not yet found any objects big enough or on course to threaten the Earth. But then again, we've not been searching for that long. There are still huge swathes of space to be surveyed and new technologies to be developed. It might be that a huge asteroid somewhere out there in the vastness of space is probably on its way towards us, and we just haven't found it yet. That's all we have for now, but before we go, we want to ask, what's the next video topic you'd like to see? Let us know in the comments, and to keep yourself updated with the latest space-related news, subscribe to our channel and hit the notification bell so that you'll be notified the next time we upload a new video. Thanks for watching.